We want to have a look at using integration and look at some of the rules that are involved in integration. So the first one we're going to look at is polynomials here. And we remember our derivative of a polynomial, so x to the power of n. When we derive it, we bring that n down and we subtract 1 from the power. So what we're going to do with integration is basically the reverse. It's anti-differentiation. So where we've got x to the power of n here, we'd have x to the power of n plus 1. So we're going to add 1 to the power, and then we're going to divide by the power, as opposed to multiplying by the power and subtracting. So we add 1 to the power and divide. So that's as simple as we get it. Remember about the plus the constant of integration. So when we integrate 5x to the power of 4, we're going to have 5, and x is going to be now to the power of 5. And then that's going to be divided by 5. We're going to add our constant, but then we can clean this up and the 5's can cancel, and that just gives us x to the power of 5 plus c. Now remember, if we want to check, we can just derive x to the power of 5. So x to the power of 5 would be, bring the 5 down and subtract 1 from the power, and we get 5x to the power of 4, so that actually works. In the more broad case, so for some function to the power of n, remember that we used the chain rule. So in the chain rule, we brought the power down, we subtracted 1 from the power, and the function stayed the same. Then we multiply by the derivative of the function. So in this case, it's going to be a really special situation that we're going to need to have the derivative of the function times the function of x to the power of n with with integrating with respect to x. So what that's going to give, again, is going to add 1 to the power and divide by the new power. And the derivative of the function of x actually gets absorbed back in, like it got created with the derivative, but we need the derivative there. This is a pretty rare case in the advanced course. So we have a look at this situation. We got the 3x squared plus 2, which is the derivative of x cubed plus 2x plus 1 to the power of 4. So that's going to give us, when we integrate it, the x cubed plus 2x plus 1 to the power of 5 over 5. And we can only do this because we've got that derivative out the front there for that part. If it's not the derivative of the function, then we can't actually do that.